Okay, so we're going to chapter 8, and that's where we will end the school year, actually. So let's start 8.1. We're going to be graphing exponential functions. And this shouldn't be too tough because in the beginning of the year, the exponential function was one of the parent functions that you needed to memorize. So the exponential function in algebraic form, it looks like b to the x, where b is a constant greater than 1. Why does b need to be greater than 1? Why can't it be equal to 1? Think about that. Well, 1 to any power is 1, so you just have a horizontal line. All right, so we have b to the x. We're going to deal with b is greater than 1. We'll do b is less than 1 in a minute. But let's talk about the graph of that guy. All right, so if x, let's just do a little chart here, little table. If x is 0, b to the 0 power is 1. So you know it's going to go through the y-axis at 1. Regardless of the value of b, when x is 0, your output is 1. What if x is 1? If x is 1, then your output is b. So you're going to go over 1 and up some arbitrary value of b. So I'm just going to write 1 comma b as that coordinate. I don't know where b is because I don't know the value of it, but I know it's up here and it's larger than 1. What if x is negative 1? Let's talk about that. So you have b to a negative exponent. Negative exponents turn into reciprocals. So 1 over b, so I'm going to be down here. If I'm at negative 1, I'll be down here somewhere, some arbitrary value. So that is negative 1 comma 1 over b is that coordinate. So your graph will look like this, and this is one that you memorized. So let's say, and let's talk about our range and our domain. So the domain of this function, or your input, what is your input allowed to be? Your input can be anything. So x is part of the real numbers. Okay, that's your set builder notation. If you want to use interval notation, you can do negative infinity to positive infinity. Either of those would work. And then your range, or your output, y, such that, notice all of your y values are above the x-axis. So y is greater than 0. Or if you're going to do your interval notation, you're going to go from 0 to positive infinity. So there's your domain and your range. So let's do an example. Let's graph y equals 4 to the x power. Alrighty, so here's our coordinate plane. If I plug in 0, I go to 1, so I know it's going to go through there. If I plug in 1, it goes 1b. Well, the value of b is 4, so over 1 up 4. And if I go to negative 1, my y value is 1/4, so way down here. So that's what that exponential function looks like. So the larger that b is, the skinnier it gets. It goes up faster. All right. So now let's talk about translating. We've done this before, all kinds of things. We've translated parabolas and all kinds of stuff, your conics. So let's graph y equals 2 to the x plus 1. And then we're also going to state the domain and range. Okay, so what might be helpful is to do a table again. And we'll pick our values, negative 1, 0, and 1 for now. Okay, so let's not do the translation. I know everything goes up 1, but let's not do it for a second. So if I just have y equals 2 to the x, my output will then be, well, if it's -1, I'll have a half. If it's 0, it's 1, and if it's 1, it's 2. All right, but this is +1, so that means you're going to take your values and add 1. So this will be 1.5. This will become a 2. This will become a 3. So graphing it on the coordinate plane, -1, 1.5. So over there, so right there. 0, 2. 1, 3. All right, not so bad. So the domain, well, remember we can put in any old x value. So this is x such that x is an element of all the reals. And our range is our y. So y, keep in mind, y is never gonna, it wasn't gonna go below the x-axis. Now that we've shifted it up 1, it's never gonna go below the line y equals 1. So y such that y is greater than 1. That's because of our vertical shift. Okay, so let's talk about what happens when b is less than 1. So b is going to be between 0 and 1. So b is a fraction. So if we think about it, when we plug in, let's do our table again. I'll do a table over here. We used 0, 1, and -1. So if you plug in 0, you're going to get out 1, right? Regardless of the value of b. Now if you plug in 1 and b is a fraction, you're going to get the fraction back. And then if you plug in -1 and b is a fraction, you're going to get the reciprocal of it. Okay, so let's think about this. We know we're going to go through the point 0, 1. Now, if we're at 1, b is a fraction. So we're going to be down here, we're going to be less than 1. If we plug in -1, we're going to get the reciprocal. Well, the reciprocal of the fraction is going to be a nice whole number, so we're going to be going up here. We're going to be at -1 and then b over 1 over b. But it's going to be a whole number of some kind. So your picture is actually a reflection. Isn't that interesting? So our domain, you have x such that, again, we're not restricted, so x is an element of the reals. Your range, y, same thing. Y will always be above the x-axis. So your range and domain don't change just because b is a fractional value. All right, so let's do some other graphs. I guess I'll reuse this guy. Let's graph y equals -4 times 1/2 to the x minus 1 power. Okay, we've got a lot going on here. So let's just first take y equals 1/2 to the x power. Let's just deal with that. And we'll make a table of values. And I'm going to use -1, 0, and 1. So -1, I get 2, 0, I get 1, and 1, I get 1/2. All right, then we've got a stretch. This 4 is a vertical stretch. So we're going to take our x values, and they're going to stay the same because there's no translation there, but our y values get multiplied by 4. So I had -1, 0, and 1. Now I've got 8, 2 times 4. 1 times 4 is 4. 1/2 times 4 is 2. So that's my stretch. All right, this negative sign reflects it, right? So what was once a positive x is now a negative x, and what was once a negative x is a positive x. So let's go ahead and do that. We're going to do negative x, and this is the 4y. So I've got 1, 0, negative 1, and this is just the 8, 4, 2 again. That hasn't changed. All right, then last thing, we've got a horizontal shift of 1 unit. We're going to go 1 unit to the, do you remember? It's to the right. All right, so we're going to do x plus 1. And this is 4y. So 4y doesn't change at all. Our x's will. So we've got 1 plus 1 is 2. I've got 0 plus 1 is 1, and negative 1 plus 1 is 0. So these are my new coordinates with all of our translations. All right, so let's graph them. All right, over 2, up 8. You know what, I'm going to move this line down so I have more room. Okay, over 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Over 1, up 4. 1, 2, 3, 4. Over 0, up 2. All right, so there we go. Alrighty, and then I think that was about it on that. Yeah, I think we're good. You could add another element here. You could add a plus 2, let's say, and then you would have to do another table. And you'd have your x values, your x plus 1s. So you'd have 2, 1, 0. And then you'd have your y's. So I'm sorry, my cat is on my counter. You need to move, buddy. Thank you. 4y, and then this is plus 2, so you'd have 8 plus 2 is 10, 4 plus 2 is 6, 2 plus 2 is 4. So that would be a, if you had a vertical shift, that's how you would do it. So then everything would get moved up 2 units. That's all. I'll see you in Zoom.